I can install now this cutter into the line boring rig. When I turn this set screw in, it pushes a wedge over. This wedge pushes up this pusher. The pusher goes against the cutter, so I can put a dial indicator here on top. This goes on over the cutter here like this. Okay, so the drive shaft goes on here. There.
Smoking.
And that's it. So here you can see where the cutter starts to grab. Look at that surface finish here.
Oh my God.
She doesn't say anything because she doesn't know what that is.
Exactly.
I will enlighten you guys. See, I'm building a line boring rig for this engine block here. So I made this bearing support, which gets bolted onto this bolt pattern.
So that is not the short block from our failed engine. That is a short block from a Jaguar which Christian bought like in September.
A little bit of a chamfer on here.
Chamfer.
Let's see if my precision works out or if it's all crap. You know, if it's crap, I just cut it out of the video. This is looking good. Yeah, you need the Makita and the 6mm insert and an extension.
So he didn't cut the thread deep enough on his first go around.
Yeah, I wonder who did that. That completes my bearing mounting plate.
And then I have to get all that stuff, and I don't know what he's talking about.
Now we're talking.
Oh, look at that. Here's his drawing. Here's the tool. So it appears we still have to make one cut and drill a hole so it can be clamped. And that's what we're going to do now. And we may or may not publish these plans on Patreon. No drawing for that steel plate.
What do you think? Of course
no.
It is a drawing. And this is what we're building, okay?
Yes, oh cool, publish that. And here's Robin also working on our lathe in my kitchen. Well, Robin is making brass screws for his masterwork. So he has to chamfer again because he drilled the hole too small.
Here, you can put that outside. We're done with this one. It's heavy.
Perfect. Of course, everybody has a steel plate lying at home.
Everybody has a stack of steel plates at home who has a machine shop, okay? Or a lathe in the kitchen. Okay? The machine shop was there before our Land Rovers, okay?
And before our kids.
It was the deal, okay? You get kids, I get a machine shop.
Yes, exactly.
You walked away with my drawing.
It's here.
From that ring?
Yes. So now we have to drill that hole here.
So if I want to drill now this hole in here to make this ring a clamp ring, okay? It's important that I align it this way. All I gotta do is use now these holes, which are precision drilled, okay? And rest my part on these holes, and then my part is 100% straight in the vise. By utilizing skill like this, you can actually use very inferior machinery to make precision stuff.
Oh my God.
Oh. The slot is 1mm, so it's 18 minus 0.5, and it will be okay.
Times 2. I mean, I don't know.
Now the difficult part on this operation is now that I have to make sure that all my tools fit into the machine, because on this machine, if I use that height adjustment, this head is sloppy, okay? That will not give me an accurate hole, so I have to make sure this is set up absolutely correctly. So a machinist knows, okay, I want to reach my depth. This is 0. And now I need to go another 18.
The hole is on that side.
That piece is right now mirror image. I have not given it a direction because the saw cut is done last and I can still flip it around in whatever direction I have. When you watch Curtis from Cutting Edge Engineering, you know what this tool does, okay?
I know what that tool does.
That's just like he does, only in small. In the center. So now I got my center set up and now I can see this dimension here, which is 50. If I adjust it right.
Can't you type it in?
No, it has to move there. And I got now here 0 and here 0. Some people will say now, wow, this is 0.035. If you have a regular M8 hole, the tolerance is actually 0.08 plus minus. So I'm within the tolerance I need for an M8 threaded hole. So I would waste my time by trying to adjust this down. It's not gonna add to the value of the piece I'm doing. Just like a carpenter who's building a house is not working to a 64th of an inch. They work into whatever they know what that has to be accurate to, like a 16th of an inch. So same for a machinist. He needs to not overdo his work, otherwise he never gets done. I have to do this countersunk hole here. I gotta use actually an end mill. And I'm not supposed to use an end mill in this chuck, I know that, okay? But again, if I change now from this chuck to a collet, it will be too short. Then I have to redo all my alignment and I'm too lazy. So I'm just gonna work this in here and hope it doesn't crash.
We need a bigger machine.
Yeah. See here, I can see how it varies in the material now. So that's good enough. And if I use now the bigger end mill, it will work.
Yeah.
Okay, in the next operation, I basically put the hole through for the tap all the way. Okay. Now in the next operation we gotta drill the clearance hole for the bolt shoulder.
Okay. That's Robin's girlfriend. Oh, there are a lot of movements on my part.
Yeah. I don't even need to watch the workpiece. Now I can cut the thread and it will work perfect. So I only clamp the tab here really lightly so it doesn't rip off. And then I just go in here until the tab stalls like this. And that's it.
And that's how Curtis does it?
Yeah, that's how Curtis does it.
And Christian has been doing that for 30 years.
And now I can cut it to full depth.
So let me explain you our dilemma with our milling machine. It's the clearance up here. So if we would get a bigger machine, we would need more clearance.
We would need a bigger house actually.
And the problem is we would actually have the clearance because here Christian could dig out the ground.
But who's gonna watch a video where I dig out this room and put a new layer of concrete in, okay?
Yes.
It's gonna drop our fuse, so we have to live with that.
Yes, and yes, we have more clearance in this room, but we cannot have any metal chips here. You need a designated room with all the machines producing metal chips. You see, Noemi films for Robin, and I film for Christian.
So this is finished now. And what I want to do now is actually slot this so it has like a clamp function, okay?
How are you going to slot this?
On our bandsaw, which has for sure a broken blade.
For sure.
Well, it's actually not broken, it just fell down.
It fell down?
Yeah, see?
Our bandsaw.
Yeah, our bandsaw is absolutely gorgeous.
Gorgeous.
Our bandsaw is absolutely awesome.
Awesome.
Yeah.
badass.
So.
Yeah.
Okay. Now I need the Toyota scraper.
Yes. Here's my Toyota scraper. It was formerly Dave's Toyota scraper. Dave, I'm sorry, you're never gonna get it back. Machinist work.
Now, a lot of work you do on a part like this doesn't technically matter, but if you show something like that in a video or you show it to somebody else, it makes just a better impression. If the parts have nice surfaces and are finished, you gotta agree, if you watch some video where they hack some welding up and it's not looking nice,
Yeah.
it just doesn't give you the impression that it's high quality. Okay, so this is good.
My toolbox. Here are all our drills, or some sort of drills, and I have to say they all look the same to me.
They are the end mills. The drills are over there. These are the small end mills, and here are the end mills in use, okay?
Again,
And here are the tabs. Then these are the centering drills. These are carbide end mills. These are other carbide end mills. Call them reamers, I think.
I don't know,
Okay.
and we have all that because we bought it.
Okay, final assembly. So when I machined this earlier, this part fit in here. Now you can see it don't fit anymore.
Change of plans. For some reason, those two parts fitted before and they don't anymore.
This is a design error, okay? This part was precision fit here before and you can see it don't fit anymore. And now when I do a single-sided cut like this, it deformed, it don't fit. So we're gonna have to change the design, drill a second clamp hole down here and cut it on the other side also. Then I will have a precision half shell where this piece goes in and this one goes on top. Same thing, but a little bit more work when I later on do the line boring operation. Because during line boring, I need to be able to take this piece in and out quickly and precisely. Otherwise, I can't do the boring operation.
Oh my God. Robin loves our lathe. So all done. All we need to do is now make another cut.
Oh, you got that, yes.
Yes. So Robin's power hammer is called Wilma. The previous owner named him that. Why is it called Wilma?
Weil er mal will und mal nicht.
Yeah. Tampering again. Filing. And we have a bad day hammer in every workshop room.
Well, Robin actually got some bad year hammers, okay? We're done with this part. If it's still screwed up, then
We know who did it.
a big failure here. Oh, look at that. This is gonna fit. Okay, this is a precision fit now. It's clamping hundredths of a millimeter. So we got, even with the bolts only lightly tightened, we got nice contact. Yeah. This is only a trial assembly to see if we have a good fit now. Okay, see, this has now enough clearance to be nicely arranged. And that's where I use the tool you brought me.
Kita.
Now I gotta put this ring in here. Oh no, it doesn't. Oh no, shit. See, I got this piece on here and this is a really tight fit, okay?
A really tight fit. It's too far.
And for that I can move my plate. I gave the plate some play.
I don't think.
What? You don't think so? I leave these loose. See, I got a bushing in here. I got one in here because these mains are still good. That's the wasted one. And this is my auxiliary bushing. So I got these now all aligned in one clean. And this still turns, okay? This is still loose here. You can see that, which is good. So it's not under any tension. Now it's clear to everyone why I put so many in, because I want this to be really solid and rugged. Yeah, it still turns now here. This is precision boring, though.
Yeah. That's gonna be a grease nipple.
Actually, this is an oil hole I put in here.
Yes, but grease nipple is a much cooler bird. Christian had to make a few adaptations to his drawings.
I'm making adaptations since a day now.
Yes, I know.
We're gonna cut cut this really nice.
So, oh my God, you made quite a few changes.
Yeah, I got like
You
reliefs.
see here the reliefs, and there is something sticking out.
Yeah, there is a pin which puts it into the correct position, and I have a handle on here. Clamp it here, nice and even. And it goes through.
Ah, without jamming.
Yeah. I want to say 6-7 Newton meters onto these. A
Okay.
little tighter. See, and it still turns.
Yes.
So this is now a 0 clearance fit. Yeah.
It's awesome.
I loosen these. Now I can move my cutter back. This piece out. See, this is now a little bit stuck.
Oh.
See?
Sorry.
I mean, it's precision. That's why it's stuck. And now I can actually go in here with my indicator. See, like this. And actually take a measurement of where I'm at.
Yes.
Okay.
So he's at the first bore.
Yeah, because we want to machine the first bore. So
Yes.
during my machining operation, I can now get in, check the bore, and then put everything back in a repeatable location, because this is absolutely German precision, okay? I can guarantee that.
Yes, but doesn't it bother you that the bolts are all on a different color?
Yeah, I have to get maybe some newer ones, okay? Get this solid again, that's why these bolts are there.
Yes.
And now I should be able to put my cutter back into position, watch it. And it works. Oh, I gotta build me now a dial indicator. Yeah.
Oh my God.
Okay, so I want to attach
So we
this.
cannot use a tie wrap?
No, it doesn't work. This will do it. Okay, now you guys gotta see here that I made a little fixture here for the engine block to mount it perfectly. And I'm using Robin's heavy anvil tripod here, and I spaced it up a little bit so it's more convenient for me to work on. I think everybody understands why a tripod is better than 4 legs. So I'm getting my engine block ready for line boring, and there's actually a problem in this upper bearing race here. I'm gonna make that visible for you guys. This is a problem caused by the crankshaft snapping in this block. It deformed this here a little bit. I'm using here some special glue to make this problem visible here. If I run now here carefully my straight edge through, just like that. Okay. You can see there is a scrape mark right here. That means there is material basically rolled up. And this is reducing that diameter. And if I put a bearing shell in here, that bearing shell may contact in this area and it may not sit solid. So the goal is to take care of this area. We're gonna put some duct tape here over the holes, so we're not gonna take chips into all cavities of the engine block during machining. So this is all closed up. Now let's set up the boring system.
So most important, we always clean up before we start a job.
Very first step, we're gonna get our boring bar bushings set up.
Okay.
Also, we have a special set of bolts which we use only for boring operations, Plastigage testing and preliminary assembly. These are not the final bolts, okay? Very important.
These are from Fabian's Discovery 3 engine rebuild. We did like 4 years ago.
Okay, these are my boring bar bushings, which I made a long time ago. I cleaned these up. They are 75.00, okay? And in order to make them hug the boring bar as good as possible, I shim them, okay? I shim them out so I can give them a little bit of a squeeze and make that boring bar nice and tight, okay? This is how I want it. Otherwise the boring bar sits too low. Okay.
Good.
No, not quite. Now it's in. We got 100ths of a shim here in between. So this bushing is sitting high up by 100ths of a millimeter. Now my bearing cap goes in here. That's the number 4. And of course I got that all nice and clean. And I put that in. Get it nice and flush.
Light.
Torque them with 40 Newton meters. Torque them with 90 Newton meters. This is a precision hardened and ground bar, 40 millimeters in diameter. Okay, that's so many inches. And put this in here and see if it fits. And it does, okay. But we forgot something, so we take it back out. Now we do the second bearing seat. And I'm not gonna seat it here in the front edge, okay? That's where my bearing block is distorted, so I wanna stay away from that.
Oh my God.
Yeah, it's nerve-wracking, I know. Now I take bearing block number 2.
Yes, for the final installment we run them down with the bolts.
Yeah, you can watch about 50 videos. Stuck a little bit here. And we seat them nicely. Before I do 90, we get the boring bar now in. Now the run out of this bar does not matter for what we are doing because we're setting up the boring operation individually per bearing. Okay, so I put it in here. And you see how nicely that lines up. I got it in now, it's nice and loose turning, but now I still got to torque it to 90 here. So it's clamping up that bushing. Okay. Now remember, we want to machine this main bearing and also dress up this main bearing, which will obviously not work if our bushing is mounted here. So we need an additional bearing here in the front. I made like a precision steel plate here. But I highly recommend not to duplicate this job, okay?
Do not try that at home.
This is definitely...
Unless I put 15,000 kilometers on that car.
Yeah.
I can do that easily.
This is definitely something you do not want to duplicate, but all drawings are available on our Patreon page. I had problems with this plate not being flat. Get it nicely tucked here.
Yes, and the only motivation to rebuild these engines is so that Christian can spend quality time with his milling machine.
Oh, I thought you were gonna say with his wife.
No.
We got these bolts and we bolt this down here.
Down here.
Where?
I don't know if...
Oh, Jesus.
He loses everything. Everything.
Obviously, we leave them loose. This is loose, obviously. This is loose, and this blade is not tight yet. I put in my precision huggable front bushing, which also has an oil hole and a through hole, so I can adjust my cutter in operation. Now I lift this up.
Oh, shit.
I put this in.
Yeah.
Let it ring.
Yeah.
Like this.
Okay.
Yeah, and I do that evenly. Now I'm gonna engage my boring bar into the front bushing. So I have more leverage.
I'm just surprised that he didn't machine a handle.
Now I can turn this and I can get this in here. And this front bushing is tighter. That's why I have to work it a little harder, okay? Now with this being aligned here, here and here, I can tighten up my bolts lightly.
Lightly? Again, we already tightened them lightly.
Yeah, I gotta loosen them first. Okay, and now I tighten always this bolt here first, very lightly. This one, and then this one. I have room here. See, this is wiggling nicely. Now I tighten these, like this.
Don't we torque them?
Yeah, 25, 26.
Oh,
26, 26.
I think that's not 26.
25. Okay, so now we got this bushing set up roughly on the block for the machining operation. But there is still one more major alignment job we have to do to make sure we don't screw this up. I give these here a little bit more torque. Now we'll take this bushing here out.
Evenly.
It's jammed up. There it is.
Hang loose.
Hang loose. There, there, there.
Yeah, you need like three 15mm sockets to do that job.
To align the boring bar, we align it now first to this main bearing, and after it's aligned to this one, we check it against this main bearing to make sure we grab the right amount of material. Now I made this little special dial indicator. I put this in here.
I hope you didn't lose your bolt.
A little thumb screw, you call this.
Oh, okay.
Okay, it's from McMaster car. Remember that there is now a little burr here in the front, so I do not want to pick up this burr. I want to go in as deep as possible with my indicator here. Watch it. Yeah, nicely half a rotation. And you see, I'm always completely far in. And now I can align the entire setup here to 0. That gets it within a hundredths of a millimeter, which is so many inches.
So today is February 1st. For your entertainment, I'm gonna switch the January girl to the February girl.
Yeah, from 2022. So here is the February girl.
Oh man, I wish I would look like that.
Okay, this is a moment where you can say something wrong. I wish I would have a calendar from you here. Isn't that something Rip would say?
Exactly.
Here I can turn my boring bar and look at that. This is already really good. And it's in contact here. See that? We use this tool here, what I bought from Amazon. And we're gonna have Vera actually doing this job now with following the camera. So she's gonna put this camera away. Here, see how precisely we can see the indicator dial, okay? Even if this is only a hundredths indicator, we'll almost get it down to half a hundredths with that. I go to this position, and we are hundredths out, and I go to this position, and we are hundredths out. And the direction we note by the direction of the writing, okay? You're gonna see now how we're working to get the final setup, and once we're done, we show you the final setup. Here, you operate the camera, okay? And I'm gonna get it to right here to 0. And now I turn it 90 degrees here. Okay, so we're in the direction of the writing, which means the hole gets tighter. That means the boring bar gotta go over there. Now let's check the other side. If this makes sense, this one, it should go opposite of the writing.
No, it's also in direction of writing.
Okay, that means the boring bar is too low.
Also a little bit less.
Yeah.
It's even.
It's even,
Yeah.
and then when we go here on the top, it's 0, okay?
So now we are at the bottom.
Everybody can see it's 0, and we're down on the bottom. Now watch it when we turn up. Look at that. This is less than a hundredths, okay? We're not going to get that alignment much better. And it's actually too far down because here we're opposite of the writing. So we are looser up here, which means we're going to take a light scrape on the bottom. Next step is we're going to have to verify now the front bearing to make sure that one is also in the nice contact position. There. And put the indicator back around like this. And I did not touch the indicator, so it should be nicely set up, just like that. And the front one is the broken one, okay? That one took a big hit and it's 0.05 out.
Yes.
Look at that, it already reads 0 to the start. This is already very good. Without adjusting our 0, okay? So our setup is pretty precise.
More than
200ths tight.
Yes.
Go over to the other side.
Yeah, 200.
200ths tight.
Yes.
Go over to the other side. Also still on the lower bearing. We're even.
Yeah, now we're on the other side.
Now we go down to the bottom, but not into the oil hole.
Yeah, more.
And we are
300.
300ths loose. That's a problem. The cutter is not going to come into contact with that bearing. So my conclusion is that I made it so complicated that nobody can follow it and we're just going to do it.
I don't understand it anymore either.
Yeah.
Snug as a bug. In a rug.
And this is of course a difficult adjustment now and we're going to make it look easy, but in reality we've been fumbling around for an hour.
Because I could see it.
That's good. So side to side from here is good. Side to side from here is also good. I see it.
No, I don't. I would torque them. So they are all the same.
Yeah, they torqued. Click, click.
Oh boy.
I'm gonna have to dress up our front bushing a little bit. It's a little bit too tight, okay? It's hugging that shaft too much and I can't turn it easily. So it's gonna cause a problem during machining because my motor is gonna stall.
Christian, right now everything causes a problem.
Yeah, this is much better. There, it's back in. We got an accuracy problem. Something is binding up, so we think our mounting plate is crooked.
So when you're working with microns, there are so many sources of deviations, and we are trying to eliminate one by one. So to prevent any warping while we drill, you know, we have spacers here and a heavy plate here. So that blade should have not moved at all.
Okay, now we got our reference surface here finished. Now we're going to clamp it up on this surface and machine the backside of this surface. Then it should be absolutely parallel.
Exactly, so one side is done and now we flip it over and fix the other side.
In female word.
So the best purchase we've made in a long time is actually that straight edge here.
Yeah, that's
And we bought it for our last Discovery 4 engine we built, where we actually had to purchase a new used engine. So here are the first set of spacers.
Yeah, we're gonna put them like here and here, okay. Now we'll put this over it. Yeah. And here. It's a little weak, that little finger.
Yeah, I know.
The spacers are sitting above each other, top and bottom, so I can clamp this up as tight as I want and it will not warp it.
Yes.
See, there's some vibration. It's not nice.
So we're gonna clamp through that hole also. Good thing is we have everything in every size.
So this gets us an M8, and an M8 may fit through here. So I got this bolt here now set in place, and here is a piece of steel in between. And if I put shim stock in here, this is exactly dialed in to grab lightly. Okay, now I can tighten this and it will take away the vibration and not distort our plate.
There's a fine dust removal.
Yeah, that's a lot more chips than down here.
Yeah. It's like moving along. I'm always amazed when Christian uses both handles and I wouldn't be able to do that.
Okay, now we need to clean up this hole.
Yes. It's all rough. Christian needs to polish it now. So now we're cleaning up the screw hole.
220 grit. So no high spots. To get rid of cutter marks on an old machine like that is impossible.
Yeah.
No more bone.
Okay.
Yeah, we'll try it now. So we got this surface machined and it should be parallel to this surface. Prince Charming is getting closer to the train station. That's what's happening.
No, we're gonna buy a new engine.
Because the problem was, when I tightened up these bolts, this started to lock up. I can tighten these bolts now, and it keeps moving. And that locked up before, because the plate was crooked, and this is now perfect, see?
Because we blamed the boring bar.
Well, the boring bar has multiple holes already in it, and this is a hardened bar. It's really tough to drill a hole through, and wherever I have a hole going through a bearing, the bar is deformed from the heat of drilling. My tools are just not hard enough to get that stuff drilled perfectly. So we're going to use a new boring bar here and drill one hole for our cutter, and that's it, instead of using this one.
So that's where we're gonna drill our cutter hole, so we can basically bore that, and in the future, that main bore.
We would turn the cutter bar around, like this. Now we could bore here.
Yes.
This way we have more room for our drive unit, which you guys haven't seen yet. I found it in the trash.
Yeah, he found it in the trash. In Robin's company. And that means something.
Yeah, you don't throw anything away if it's out of steel. I got here a multi-fluid solid carbide cutter.
High speed.
Which does not belong into this machine whatsoever.
Where does it belong to?
Into a good machine.
This is a good machine, served us well for over 25 years. Oh my god, we have to fix now the thread of our milling machine.
Yeah, I don't know why I ruined it, but maybe I hit it with the hammer before it was all the way out. Tighten it down. Right there. So I got this nice and solid build up here.
You can drill here.
I can drill right through. It's just enough of a surface so the drill hits something straight, because this is hardened, it would just wander away.
So now we use the edge finder, just like cutting edge engineering.
So we go with a solid carbide 8mm drill.
Yeah, maybe we should take it off also on the other. Yeah, it's true.
That looked easy now on camera, okay, but drilling hardened stuff is always challenging.
Oh, the hole has to get bigger.
Yeah, it needs to be 12mm.
Oh,
So,
shit.
let's see if this works now. Oh, there's the chip, see? The drill broke.
Yeah.
That's bad.
Oh, I think so that's the last drill we have in that size.
And this one is resharpened.
Yeah, it's
Well,
true.
it went through. Well, this is really sad because that was a brand new, really good drill which I bought. So now the drill goes through and we got it nicely deburred. So our boring bar is finished.
And we hope we didn't distort it.
Yeah, and we can continue where we left off 2.5 hours ago.
Oh my God. It's a long day and the sun is shining so nicely outside.
Well, it's already getting dark, so you spent quality time with your husband in the workshop.
Who told me, please engage more.
Okay.
There's a hole.
There's the hole, see?
Oh.
And the hole does no longer get stuck. So our cutter is gonna catch the edge now with 0.0000 And now watch when I go here on the top. Perfectly zero, okay?
So you can hear the fire.
It's such a cold day we had to actually get the oven going.
Yes.
Okay, now I haven't told you guys why we are line boring this engine block. This block is out of Jaguar XF and it snapped the crankshaft. So it actually got around 180,000 kilometers on the block. I bought this block knowing that it snapped the crankshaft. And what typically happens when the crankshafts snap, they distort the front, first and the second bearing at a minimum. In some cases they even throw out the entire front of the engine block, or they hack everything into pieces. But on this one everything is clean. We got only a minor damage on the front first and on the second main. Okay. The damage on the main is basically main number 1 is out of round by 0.06. The tolerance here is actually 0.005, so roundness is extremely critical according to Ford, and ours is in an oval shape. When you measure across, it's quite accurate. If you measure up and down, it's 0.06. That's way too much, okay? The second problem what happened when the crank died is that this lobe running in between those two mains hit the sidewall of this bearing block, and that rolled up a burr into the bearing surface area here. This is what I indicated as red here and here. This burr has a height of about 0.1 millimeter and it's untouched and unharmed back here. I can measure that with my bore gauge, okay? If I go in here and measure this bore, it's perfectly 75.005 millimeters. Same as this one, measures perfectly round, and same as this one, measures perfectly round. So theoretically we gotta only fix two things. We gotta get this one round again, and we gotta machine this burr away. When I did the alignment job of our boring bar today with Vera, we found that this bearing race here is actually not concentric with this race, and it almost looks to me that this is not a consequence of the crankshaft snapping, okay? I think it was not concentric out of the plant. We're gonna get this boring bar in this alignment. And that's what we got now dialed in, and we're about ready to go to make this cut. So if everything goes to plan, we're gonna see a lighter cut here, a stronger cut here. On this one here, we maybe want to scratch into a Sharpie line, okay? That's it. So Sharpie line scratch, light cut with 100ths, little heavier cut with 0.02 to 0.03. That would be perfect. And in order to machine these, of course, we have to get the top caps further down to have material again. So we're gonna machine the flatness here of this upper bearing block here by 0.1 millimeter, as well as here 0.1 millimeter. This brings these caps further down into the block, and it gives us material, and we're not going to run out of material. While we're here, I want to explain how the cutter works, okay? This is a clamp-on cutter, and it goes onto my boring bar. That's why the boring bar needs to have a hole, because the cutter comes through this hole and it scrapes it around like this when we feed it here through. And we can adjust the depth of this cutter with a little pusher and a wedge assembly down here. When I turn this set screw in, it pushes a wedge over. This wedge pushes up this pusher. The pusher goes against the cutter. The cutter is also locked here with a set screw, so I can put a dial indicator here on top and dial that cutter up, for example, by 0.005 millimeters, very, very accurately. So I can increment this up and up and up to make my hole larger. That's the plan. And if that works, okay, you're gonna have a happy ending in this video. If it doesn't work, this block is gonna be trashed.
It's gonna go to the train station. So, and 100 is the thickness of his hardened aluminum foil. And I know it's not aluminum foil. I just like to call it like that because it's so flimsy.
And it's 100.
Oh my God.
We're cutting this amount of material into the mother material of the block here, and maybe twice this amount of material into the mother material of this side of the bearing block. That's the plan. Okay, so this is the cutter. Here you can see this is the wedge where it rides up and down when I push it in, and it pushes that cutter up slightly, okay? So it gotta go in there like this. I put this in here, put this in here, and this gotta go over it. There. Now I can drive this wedge in here with this little set screw, and that pushes this cutter up. That's as simple as that is. And in order to actuate that cutter, I put it in there like this. Yeah. The top half goes on, and we put 4 bolts in.
So what he's basically doing is a mirror image of that cutter, because our milling machine we are using only rotates in one direction.
Yeah.
And that is the opposite direction. Nice.
Yeah, looks good.
And it's in the right direction. Please check it. How do we get the cutter now to correspond to our readings?
That's why I'm waiting for Amazon.
Oh my God. It should be delivered by no later than 2015, so 8:15 p.m.
I can install now this cutter into the line boring rig right here. Now I put in my bushing in the front. There. Actually, it does take now also 7, and it would still work. I'll lock up this one. Yeah, it's still good. Okay, see this hole here? Down here? Can you see that now here?
Yes.
This is how I adjust the cutter now upwards.
So when Amazon was just here, and I could see on my app that the Amazon truck was standing outside. It's awesome. Amazon is just...
Oh.
If I would have dropped it now. I can't believe that thing cost 50 euros. It's not me to tell you.
55. This is a micron indicator. This is really incredible. There's the dial indicator I got from Amazon, and I machined like a little flat tip here for the front, okay? This one is not serial condition. I did that already yesterday. And then this goes on over the cutter here like this. You can see that. I locked down the mag base, and now I can zero this thing. Okay, there you go. And if I now go in here with my Allen wrench onto my cutter down here below, That's how precise I can adjust this cutter now at any time using my little wedge and cutter setup and my new Amazon indicator for 55 euros.
Yes, I wasn't allowed to help.
This thing here,
Yes, I hope everybody knows where that's coming from.
I already machined like special pipe for it here. This gotta go in here. This bolt gotta go in here. Okay. And down. Good.
No,
What are you laughing about?
that thing is like 100 years old.
This is our drive unit.
Oh my god. Now that thing is out of Robin's.
Okay, the housing is a little slipping, okay? It's not that bad. Where's my drive shaft? Okay, so the drive shaft goes on here. Very simple. There. Close this up here. I had to fix all of this. None of that stuff was still working. Now align this here roughly. And that gotta go on here. See right there? Yeah, there you go.
Well,
That gives us the necessary stiffness
yeah, I got.
between these two units. And then I gotta move this.
It's unbelievable how fast that oil is stripping off and
Yeah.
running
So,
somewhere.
and there we go.
And it's not yet set up, so don't cut it now. Otherwise,
No,
I'm going to be
it's not.
stressed.
It's not set up. We still have to machine this piece and this piece.
Yes.
And I can move now the cutter, see here?
Don't move it. Don't move it. Oh my god, he's going
Very
to move
simple.
it.
With my little drive shaft, it's no problem at all. But this thing is running quiet. You might want to show a picture to Robin.
Yes, I will do that.
This bar is now aligned within 5 micron, okay? As good as I can get it with this indicator. We're ready to do the machining now because the bar is aligned. It only took like 2 days and we're ready to go now.
2 days, Christian. You have been working on that setup for a week now. After work, before work, with me, without me.
Yeah, but the alignment took yesterday, the full day, and a little
8
bit on
hours.
Friday
Yeah.
already, yeah?
Yeah.
So that's what I meant. Now, I do want to show everybody something because I know we're going to get comments. First of all, in a setup like this, the straightness of the boring bar is not extremely critical because we're moving it between 2 fixed bearing blocks only for a short distance and we set up the cutter for each main bearing. So if there is a bow in this, the bow stays constant basically in the area where we move it for machining. When we then go to the next bearing race, we have to readjust the cutter. Otherwise, the TIR of the boring bar will affect our precision. I hope everybody can follow me without making now another sketch. So remember guys, this is a micron indicator, okay? So this is a unit which does not exist in the inch world. And look at that, okay? We got here about the distance of our engine block mains. And look at this boring bar from Bosch. This is extremely good. So we don't have to worry about this run out if we do the machining like I said, and we adjust the cutter for each individual position. I got this bearing in here to help me guide it in. So it doesn't get stuck.
Talk to 6 Newton meters.
7. I changed it.
Oh.
We first have to machine this bearing block down so we have even
Oh
material to
no. Oh my.
cut. So we take this bearing block out. Machine shop time, okay?
Yes.
And it goes in there like this. And now we're gonna go. That's 0.12 shorter now. So that's 220 grit sandpaper. I just wipe it here to see if I have good contact point, okay? And now I have to live with the comments that I didn't do that in a figure 8. You know, that surface is way too small. Okay, and look at this contact pattern from my old machine here. This is really incredible.
Yeah.
In this application, we can use a little hammer here. These are not the final bolts. These are our test bolts. We torque them to 40 Newton meters. 90 Newton meters. And we give them some extra stretch, but not quite the full spec. Oh, come on. And here in front of my bearing, back of my bearing. Okay, start it.
Smoking.
And that's it. We're through. Right here. Now I gotta unlock the cutter set screw here, grub screw, I think.
Yes.
So we're gonna give it 100ths. Now we give it a little more.
Yeah. 1200. 14, 15, 16?
200ths.
Oh my God, I hope you're not making the hole bigger.
No, that would be pretty bad if we make
Yes.
it bigger.
200s.
Yeah, 200 is nothing, okay? That's not
That's-
even on the scale for people working in inch. Oh, we're gonna get a lot of inch haters. Oh, that sounds so beautiful. Good? You happy with this cut?
Yeah, but now you went from here to here.
That's
Earlier
okay.
you went from here to here.
Yeah. I'm not gonna get a place in heaven.
So,
Hang on.
yeah.
So here you can see
Yeah.
where the cutter starts to grab, okay? And you can see this is a really smooth surface. So we go in another 200ths, okay?
Okay, so we have like 600ths more to go. That
Yeah.
means 6 cuts.
200ths now.
Yeah.
Oh. And we still hear interrupted cut. Okay, yeah, we still have an interrupted cut in the upper bearing shell. So we're gonna go slow. We got all the time in the world until Vera needs to pick up filler.
Okay, because he hurt his foot and cannot walk.
Same procedure as every year. Put our dial indicator on here. Now she trusts me slowly, okay? We zero it out.
Yes.
Okay, look how precise I can do that.
Yeah. Oh, perfect. Awesome. Okay.
So, and we're ready for the next cut. Oh, the drill press from Robin.
Apparently you're not through. Now,
Okay,
there's not a noise anymore.
good.
So we're going for another 200ths.
Fourth one.
Yeah, the third or fourth one. Wow.
Good.
So one cut takes 1 minute and 15 seconds.
Yeah.
Oh my God. So it's starting to cut at the bottom. I think you can see the blue.
Yeah, so hopefully we're not out of spec and we have our 10 micron of material left, what we can machine away now. It's our measurement. Let's hope we didn't blow it already. We're hundredths over, okay, 10 micron over. Here next to the oil bore, we are close to zero. So 45 degrees out, we're 5 microns over. So I just say it's going to be all good.
Yes, I can follow you now because we've been talking about that the last 4 hours.
The spec is 75 plus 0.02. And we are right now in the worst spot at plus 0.012. Okay, that's the worst spot. So we are almost in the center of that band given, but we also have a tight spot where it's 75.005.
The Plastigage test will decide.
That's correct. It's the holy grail test.
Yes.
Okay, but I gotta show you guys the finished circuits here now. Some workshop who does that line boring, you know, they do a honing process afterwards. We don't. We have to get the finished surface right from the cutter. That's the big difference, okay? We do not have a honing option later on. Look at that surface finish here.
Oh my God, it's awesome.
This is really incredible. Equivalent to 800. Look, and it's already polishing just by using emery cloth.
Yeah, do it down there too.
Okay.
And now we're not going to measure it because I don't want to know that the emery glass took off those 8 microns.
No, this doesn't take anything off, okay? Dad, this is incredible.
That looks like a nice finish.
It looks really nice.
Yes.
And now we can do the second one.
Oh, really?
It's too late for you.
Yeah, it's late.
Okay, let's put that one in. I'm gonna give it a rub again.
And all nice.
Absolutely beautiful. This one should be completely easy because all we gotta do is back up our cutter, make a cut, measure it, do the final cut. Just slowly.
Seeding. So Christian and I, we basically spend every day he's not at work, all day long, together.
Doing this kind of stuff.
Doing this kind of stuff.
And other stuff.
300.
One full turn.
So that is like what?
Something.
Okay.
Insert our boring bar. This is all by now standard procedure. So that cutter is gonna catch here now. See? And it should not catch on the bottom. And it doesn't.
The top here is missing.
Okay, we're gonna have to reposition our drill press.
Yeah. Oh, we do?
Yeah.
Why? Oh my God. The entire setup.
No, this setup is all easy.
Wait a second. No, it's not. It's not nice. That is high precision work, you know.
You ready?
Yes.
It's now a heavier cut.
Oh my God, it sounds different.
Good. Look how it already grabbed here. This is how distorted this block is. This one
Yeah, it
was
had a
grabbing
burr, you know. I want
She's
to be done.
finished.
Yes.
because she's spending too much time with me. So we're gonna engage it by 300, so 30 microns, and that's 60 microns in the diameter. That should,
Oh my God.
that should get us really close.
Holy cow.
Now that's a large cup.
We're gonna adjust the cutter to 100, which means it's gonna take 200 off, and then we hope we're done. So my job is to put a little bit of oil here. And again, it's late in the evening and I should not be doing stuff anymore.
Okay, watch it.
Yes, and then I put a little dab of oil in here. 100.
Wow,
Oh, too far.
that's okay.
Oh, that's too much.
Yeah, I can't help it.
Oh my God.
I'm gonna have to sleep on the couch now. That's it. Final measurement now.
Yes.
It may now look all easy to you, but getting this to work before doing the final cut, you have to get all the bugs out of the process, okay? There was a lot of debug work, is what we call this in the machine tool business, to get this process just perfect. And now, after it's all perfect, we show it to you and you think, oh, this is so easy. But
Yes.
no, it's not, okay? Until we had all those tools just perfect. You see how tight that is. It was a lot of work.
Yes, and the hardest part is training your little helper.
It cleaned up the lower bearing in the front half here. Can you see that?
Yes.
That's how large the spur was because the crankshaft kissed that edge.
Yeah. And?
We are 5 microns too tight here. It depends, you know, my gauge is really now at its limit of accuracy. This side here is tight, this side is loose, okay? And there is a spot here, there's a little bit of fantasy where it's too tight by 5 micron. See that? If we run the cutter through again, it's risky.
Yeah.
Yeah. It cleaned up the edge here, it cleaned it up nicely here.
I made it.
Yeah, you made it through the evening. Only a test fit. Okay, I got the Plastigage test completed. And this time we're using Kolbenschmidt Plastigage
Yes.
test. Do you see that?
Yes.
Really nice, okay? Everybody remember that the tolerance band on the main bearings is 0.027 to 0.063 in millimeters. And that's so many inches.
Okay.
Somewhere between these two we have to be. And if we start here on our main one, okay, we are in this area, 0.038. I'm actually happy with this one. This is also one which I machined, okay?
Ah,
The second one is I machined that one also, but I'm not so happy. And we remember this one was 5 micron tight. Okay? This one is more towards this end.
okay.
0.025. So it's too close, in my opinion, to the specification. Number 3 is original, untouched, and it's definitely too tight.
Oh my God.
And then number 4, untouched, too tight. So the one we machined, in my opinion, is nicely in spec. The one we touched only during machining is like borderline, and the 2 OEM ones are too tight for my taste. Okay?
So what are we going to do now?
We're not going to install it like this.
Oh my God.
No, this
So
was
that's a
a waste
stop.
of time.
And money, because that shot block costs a lot of money.
We're gonna fix that, of course.
Oh, we
but
do?
We're not gonna install it like this, and we're not gonna fix it in this video, because the video is already 1:05. Half of our audience will look over there. They already fell asleep.
Okay, this will be outtake number 2, because we may or may not have used the wrong crankshaft for our Plastigage test, because we have so many lying around.
Everybody driving a Discovery 4 has a spare crankshaft, okay? And it's possible to confuse them. So I redid the Plastigage test. I have now actually a test from 2 crankshafts, which makes it even more interesting. This is a new crankshaft which I bought for 1,050 euros out of Poland, and it's a 2024, okay? This is a very new crankshaft, and it was a lucky buy, okay? It's not always that somebody has one like this for that price on stock. So you can see the first one, which was the most damaged one, is 0.038. The middle of the tolerance band would be 0.044, but I might be wrong. The second one, which we touched, okay, we also remachined it, is clearly tighter than 0.038. So we got a difference from this one to this one, which is not nice. It would be nicer if they're all even. Then the next one, which is untouched, is definitely tighter than 0.038, but not on the lower tolerance band. So is the last one, which we haven't touched. It's definitely tighter, but not on the lower tolerance band. So I'm actually happier with the ones I machined from the size with this particular crankshaft. The crankshaft also goes into this equation than I am with the OEM ones, okay?
And by the way, Christian bought that crankshaft like in August or September when he bought the Jaguar block. Now we're shooting outtake number 3, because we may or may have not used OEM bearings.
Now that was a confusing way to explain it. I just couldn't leave it the way it is, okay? I had to play around a little bit more. So I used a different set of bearings, okay? I took the King bearings out in 3 locations, and I put OEM bearings in those 3 locations, and we get a different result. Now this is still the King bearing, where I was actually quite happy with, okay, because it has 0.05. That's the one we machined. The second one here is now with an OEM bearing 0.050, okay? Mid-range is 0.045, so we're really close to mid-range. Now the third one, unfortunately, is now a little bit above 0.05, so maybe 0.054, something like this. So this is 100ths over mid-range on the looser side. And the last one is perfectly 0.05, okay? Mid-range 0.045. So I like this better than the tighter end, and I tell you the reason. This engine block, because I did machining without honing, is gonna have a concentricity error, okay? The 4 bores are not in line anymore. They are probably pretty close, but still, it's not gonna be perfect. And that's why I decide to run rather here on the looser end. above mid-range than on the tighter end, below mid-range, because I think it's gonna help to equalize that eccentricity error I may have. And I think it's gonna be around 0.008, my eccentricity error on the second bearing.
Yes, I think when it's spinning around with 2000 RPMs, it's just gonna float in the middle if it has enough room.
This is the setup we run. We run 3 times OEM bearings and 1 king, because the king bearings tend to be a little bit on the tighter end. Also depends on what size OEM bearings you have. They have 3 different sizes. Look how nice those OEM bearings. They are out of the engine from Prince Charming. Look at that.
Oh my God.
It's like,
yes.
that's 180,000 kilometers.
Well, he dropped it. Oh my God.
Dropped his index cards. If you can pull a bearing and it looks like this after 180,000 kilometers, okay, it is a good design. They actually look cleaner than the brand new king bearings.
We got to stop now because Christian has to edit all that shit for tomorrow.
Yeah. Let's take the 4 pictures in a row for documentation.
Yes.
And this pretty much completes our video this week. We want to thank our Patreons a lot for their support, and
We'll see you next Sunday.
with what?
Not a running engine.
But probably with a short block assembly video. And I got a project coming up where we put a fuel burning heater diverter valve into a Discovery 4. Okay, that's that missing link, what people miss when they upgrade their fuel burning heater with just using the gap tool and the remote, and the car still doesn't get really nice and cozy. You're missing the diverter valve, okay? And we're gonna do that upgrade. That might be the video on next week or after next week.
We have to buy another car because Philip passed his driver's license test and right now he's driving my Discovery 3.
And he likes it a lot.
And he